Have you ever wondered what tiny particles make up the world around us? The air we breathe, the water we drink, the food we eat. Welcome to a journey into the minuscule world of atoms, the building blocks of matter. Here, we will delve into the origins of modern chemistry and the evolution of atomic theory, exploring the taxonomy of chemical species and introducing the periodic table. In a world before the advent of sophisticated scientific tools, Greek philosophers Democritus and Aristotle pondered over the nature of matter. Democritus believed that everything in the universe was made up of tiny, indivisible particles called atomos. Aristotle, on the other hand, proposed that matter was continuous and could be divided indefinitely. This dichotomy of opinions set the stage for the centuries-long quest to understand the structure of the atom. Fast forward to the early 19th century, when John Dalton, an English scientist, provided the first scientific theory of the atom. Dalton proposed that each element consists of atoms of a single, unique type, and that these atoms can join together to form chemical compounds. This was a groundbreaking revelation that set the stage for the development of modern chemistry. As scientists discovered more and more elements, they started to notice patterns in their properties. This led to the classification of elements into metals, semimetals, and nonmetals. Around the same time, the concept of the mole was introduced, a fundamental unit in chemistry used to measure the amount of a substance. The early attempts at organizing elements were based on their atomic mass. Johann Dobereiner grouped elements into triads, and John Newlands proposed the law of octaves. However, these classifications had their limitations and were not universally accepted. The real breakthrough came in the late 19th century, when Dmitri Mendeleev, a Russian chemist, and Julius Meyer, a German chemist, independently proposed the periodic table of elements. Despite working separately, both scientists came up with similar tables that arranged elements in order of increasing atomic weight, but also based on similarities in their chemical properties. Mendeleev's contribution in particular was remarkable. He even predicted the existence and properties of elements yet to be discovered, leaving blank spaces in his periodic table. As these elements were discovered and their properties found to match Mendeleev's predictions, his periodic table was widely accepted. Today, the periodic table we use is a refined version of Mendeleev's table, with elements arranged in order of increasing atomic number, which is the number of protons in an atom's nucleus. Each element has a symbol, and elements in the same column or group have similar chemical properties. In summary, the journey to understand the structure of the atom and the organization of elements into the periodic table has been a long and fascinating one. From Democritus's indivisible atomos to Dalton's atomic theory, from Dobereiner's triads and Newlands's octaves to Mendeleev's and Meyer's periodic table, each step has been a leap towards a better understanding of the world around us. So the next time you look at a glass of water, a piece of metal, or even the air around you, remember, you're not just looking at matter, but a fascinating world of atoms, elements, and compounds that have been the subject of human inquiry for centuries. This is the beauty of chemistry, a science that connects us with the fundamental particles of the universe.